Okay, guys, we have 2 more questions. Let's do it. Let's try question 23. A 3.30 gram sample of glucose was placed in a bomb calorimeter, ignited and burned to form carbon dioxide and water. The temperature of the water changed from 22.4 degrees Celsius to 34.1 degrees Celsius. If the calorimeter contained 850 grams of water and had a heat capacity of 847 joules per degree Celsius, what is the delta H, or the enthalpy, for the combustion of 1 mole of glucose? Please note, 1 mole of glucose equals 180.16 grams. Now, like I've said before, guys, I like to read, reread, write down what I'm given and what I need to find. So, I'm given 3.30 grams of glucose. I know the temperature changed from 22.4 degrees Celsius to 34.1 degrees Celsius. I know I have 850 grams of water. I know that the specific heat capacity equals 847 joules by degree Celsius. I also know that 1 mole of glucose equals 180.16 grams. And I'm asked to find the delta H, or the enthalpy, for the combustion of 1 mole glucose. Now, this is definitely a thermochemistry question. So we realize we're involving Q, which is heat. What my professor liked to do, was she would write down what we were looking for, which was always Q system equals negative Q surroundings. And then what she would do is she would then identify what the system was and what the surroundings were. Now, if you guys remember, the surroundings is what the outside environment is, and the system is what we want to focus on. So in this case, guys, the system is the combustion reaction of the glucose. Or you can just say reaction. And then we know that our surroundings equals the calorimeter, or the bomb calorimeter. Now, if you guys remember, Q system, or Q, equals negative MCH, or delta T, or MCAT, as my teacher would say. However, this is a bomb calorimeter question. So that means that we have not only the water to deal with, but we also have the bomb to deal with. And if you guys remember that the mass in a bomb, or the calorimeter itself, does not matter, but the specific heat capacity and the change in temperature does. So, that's why it's important to also realize, guys, that the specific heat capacity we are given is not for the water, but for the calorimeter. Because remember, guys, the specific heat capacity of water is always 4.184. So if you see a different specific heat capacity, but water is involved, and it says a bomb calorimeter, you can be certain that the specific heat capacity that they're talking about is the specific heat capacity for the bomb calorimeter. So in this case, guys, we would say that Q system is going to equal negative Q water plus Q bomb. And if you guys remember, that means that Q system is going to equal negative, as my teacher would say, MCAT plus CAT. So M is for mass, C is for specific heat capacity, and the delta T is the change in temperature, and which you all have, guys. So Q system is going to equal negative, we were given 850 grams of water, times 4.184, like I said before, guys, because that's a constant, times the delta T, which is, in this case, you would subtract 34.1 from 22.4, which would be 11.7. And as a matter of fact, I'm going to move a little bit over to the left a little bit so you all can see. So Q system is going to equal negative, like I said before, 850 grams times 4.184 times 11.7 degrees Celsius. And then we would add the Q bomb, which is going to be 847 joules per degree Celsius for this calorimeter, times the specific times the change in temperature, which is 11.7. And so my Q system, or my enthalpy, which equals delta H, should equal negative 51,519 grams. .78 joules, I'm sorry, I apologize. Which would also equal negative 51.52 kilojoules. Now that's not our answer yet though, guys, because the fact that this is the enthalpy that's given for 3.30 grams of glucose, not for 1 mole. The problem wants the enthalpy for 1 mole. So what we simply do, guys, is we're just going to simply take what we found, and we're going to do a ratio. So I'm going to put grams on the top, and then enthalpy on the bottom for both. Now you don't need to. You can flip it, but in either way, you're going to have it where you have, for every 3.3 grams of glucose, I am given negative 51.52 kilojoules of heat. And for they gave us the molar mass, so for 180.16 grams of glucose, there's going to be X. So what I do, guys, is I just cross multiply, so 3.30X has got to equal negative 9,281.81 kilojoules. And then, so my X is going to equal negative 2,812.67 kilojoules, which then X would equal negative 2.81 times 10 to the third kilojoules, which should be answer option 1 on your problem sheet. And you finally have your answer to this hot question.
The Teaching Center, UF's Learning Resource Center.